Okay. Today is June 17th, 2020. This is the Data Protection Workgroup meeting. This meeting will be recorded and uploaded to YouTube. So today we have a few things on the agenda. First, Ben will give an update on data populator. And then we also will give an update on the container notifier proposal. And if we still have time, we will just give a quick update on the voting group cap, which we're actually going to have a review meeting tomorrow. So let's get started.
Okay. Yeah, so this is I'm going to attempt to keep this short so we have time for other things. This is actually partially a review of a presentation I did a couple months ago wherein I introduced my vision for data populators. I've added some slides and some illustrations to try to help make it clearer, and I've also added a little bit of new stuff at the end based on my thinking from the last few months. So let's try to launch into this. Okay, so I guess I didn't include any preamble in this presentation, but there is a prototype sort of hello world data populator out there that I put on GitHub that you guys can look at that sort of demonstrates these ideas. And what I'm going to do in the slides is sort of walk through how it works at a high level. And then if you're interested in the code, it's on GitHub. You can look at it. So, and again, I picked a hello world data populator just so it's not specific. I don't want people to get hung up on details of, you know, backup and restore or any sort of specific implementation. So this is just focusing on the populator part of it. So in this example, I have my CRD type is called hello. So I create a CR called my source that has some contents that tells the populator what I want to go into my volume. And in the case of the actual hello world populator, it's just a string that gets written to a file, just to prove the concept. So in this example, the user would instantiate the CR in his namespace. I'm using the default namespace here for my illustration, and he gives it a name. And then in the next step, the user creates a PVC, and he populates the data source field of his PVC, pointing back to that instance of that hello object. What happens now is the external provisioner sidecar sees this new PVC, like it sees all PVCs, but it looks at the data source and says, I don't know what a hello is, so I'm just going to ignore it. And nothing happens. But in this particular example, I have the hello populator also running. So the hello populator will see this PVC, and it will see that it has a data source of type hello that it understands. And so what it's going to do is it's going to create another PVC in a hidden namespace. I just call it hidden for this example. That looks a lot like the original PVC. It has the same size, the same storage class, the same volume mode. Some other fields are copied over. I set the access mode to RWO always. And most importantly, I empty out the data source field. So this new PVC that I'm creating looks a lot like the original PVC, but it's supposed to be empty. And it's in another namespace. So the external provisioner sees this new PVC that I'm calling PVC prime, and it goes ahead and creates an empty PV because it knows what to do with these.
Ben, can I interject a question real quick?
Yeah.
So one of the questions is location of PVC of the volume, so the particular host it has to attach to. And I know there's two different sort of modes, and one of those can be driven by the workload. And
the bind on first use or whatever.
Yeah, exactly.
Yeah.
I just want to make sure that you cover that true part of it.
I have not tested it, but I understand how that works, and it should also just work. The trick would be that you know, you'd have to copy those fields from the PVC, from the original PVC to PVC prime.
Yeah, and my worry is, when are those fields populated? Are they populated? I guess they would be populated before the external provisioner would act on them. In which case,
okay, so the user creates the PVC.
Right, so
And
it's the bind on first use versus the annotations that the storage controller puts on there when it decides where to go. That's what I'm worried about.
isn't bind on first use part of the storage class? I believe that
Right,
the field where you enable it is on the storage class.
sure.
And so
What I'm saying is what it matters is you don't know that you will be able to schedule the real
oh,
pod
yes.
to
No,
the
no,
same.
I get what you're getting at, and I have not tested it, and it definitely deserves testing, but I don't see any reason why this scheme couldn't be made to work in the bind on first use case as long as we copy everything appropriate. And you know, the Hello World populator was an example, and it could be expanded to validate those kinds of things, and say, yes, it actually does work.
So the problem is going to be if you create this secondary PVC and you have wait for bind or what, or sorry, wait for consumer set, then the second PVC is never going to get provisioned, right?
No, it will. So the trick is making sure it ends up on the right node. So where was I? I was at this stage in the sequence. The external provisioner sees this new PVC prime, creates an empty PV. It's not namespaced, and then the bind controller binds them like it normally does. So here's the population pod. So then the populator will create a special pod attached to PVC prime using an image that's specific to the populator that knows how to do whatever it needs to be done. And that pod will be constructed with command line arguments that are pulled from the original CR so that it knows exactly what to do. So the populator pod will start up and do its thing and write the data into the PVC prime. And then the populator will wait for that pod to succeed. If it fails for any reason, you just restart it. You know, sometimes.
Doesn't that mean then that where that pod gets placed is where the P will determine where the PVC gets placed?
Yeah. So what I was getting at is in the case that that Andrew mentioned, we need to make sure that this pod ends up in the same place, and I imagine there's a way to do that. I don't know what that is.
Yeah, because I don't think we know, right? Because that's kind of the point is the pod gets placed for some reason that's outside of the PVC spec.
But we should be able to replicate whatever logic exists that holds off the original PVC creation or the original PV creation. We should be able to replicate that logic somehow.
Yeah, it sounds like we'd have to wait for the pod to get, so we'd have to wait for the pod to actually get, the pod that wants to use it to actually get instantiated and then fill in the
Right, but there's no reason we couldn't do that. That's what I'm getting at.
So the external provisioner right now, I just made a fix so that if it sees this generic data populator data source, it's actually not going to do anything. It's going to skip it. So then that allow an external data populator to control when to create this PV.
Yeah. So as you can see in this sequence, nothing has done anything with the original PVC, my claim.
Yeah.
The case is without a pod, if your PVC is wait for the first customer, it will not be provisioned.
Right.
It has to know where the pod is first, and the pod is created, then the PVC can get provisioned. That's the current logic of the provision.
I guess Ben's argument here is that we could modify that logic to be aware of this special case and basically handle the PVC prime the same way it handles regular PVC.
Yeah.
One of the problems.
And furthermore, what I was going to say is the populator pods will probably have to replicate that portion of the logic from external provisioner to get the correct behavior, because a lot of what the populator pod does is it kind of tries to mimic what the external provisioner would do, but without any of the CSI stuff, because it outsources that through the creation of the second empty PVC. But yeah, there's going to be tricks if you wanted to end up on a specific node. You would have to wait for the user's pod to get scheduled to a node, and then make sure that your populator pod goes to the same node,
That's exactly my point. My point is that scheduling, I think, ends up in an annotation that gets written into the PVC when it's that case. So it basically says allocate and attach to this node. And then in that case, you would want to rely on that, and you wouldn't want to preserve the wait for first consumer state, because you wouldn't want it to wait for your shadow PVC.
Well,
right?
you could make the second one wait for first consumer and then just ensure that the consumer ends up on the right node and populates it there so that the PV ends up there so that when you rebind it to the other PVC, it's in the right place.
I don't think you'll know, and you won't know where to go until you get your first consumer of the original PVC, right?
Right, and so you'll sit and you'll wait, which is fine. Like we can replicate that aspect of the external provisioner. If the external provisioner would be waiting, we can also wait. And if the external provisioner knows where it needs to put the PV, then we know where to put the PV.
Yeah, I think you just need to call out that, because that sounds tricky, and
I hadn't thought this through, so this is good feedback.
Yeah, I think it's doable, but it sounds tricky.
Yeah. Okay, so I'll continue with the normal workflow where we don't have to worry about wait for first consumer. So the populator then waits until this populating pod succeeds. If it fails, it just retries it, so we can handle nodes going away or pods getting evicted or whatever until eventually this PVC has the right data. And then here's the trick. After the populator has confirmed that the pod has successfully written whatever data needs to be written into PVC prime, we update the claim ref on the PV to point back to the original PVC. And this is perfectly legal. Then we wait for the bind controller to notice that and update the binding. So now the original PVC is bound to the PV, and PVC prime just becomes lost. This is a state that a PVC can go into when the bind controller doesn't know what happened. So now this PVC is just sitting there unattached to anything. At that point, it's safe to clean it up because once the PVC is no longer attached to the PV, you don't have to worry about what happens when you delete it. And the actual populator controller puts a bunch of finalizers on things, so you got to clean those up too at this point. And then I cover the last step is usage, where the user's pod binds to or is attached to the claim and it does its thing. So in the case of wait for first use, we would have to wait for this pod to come into existence before we did any of the other things. But that's, I think, a solvable problem. And that's how it works today. That's the proof of concept. It's a little bit hairy with the second namespace and the second PVC, but it does work, and it doesn't require the CSI drivers to know anything at all about what's going on. They say, oh, I'm creating an empty volume. Okay, that's fine, and they do it. The other things I wanted to talk about is error handling. And sorry, this is just a wall of text. So when I first did this design, I was just trying to get it to work, and I wasn't thinking about, well, what happens when the user puts bad things into their data source field, because the Kubernetes actually does do a little bit of error checking and validation on these fields. So when we added the any volume data source feature gate in 1.18, we kind of removed some of the validation that no longer made sense with this new feature gate. What that means now is, like, nothing is, if you put garbage into the data source field, nothing is going to tell you that you put garbage in there, and the system will just hum along happily. So normally the thing that's responsible for giving you feedback is the external provisioner sidecar. It'll look at what you put in the data source, and it'll say, oh, I see you, this is a snapshot. Oh, this snapshot doesn't exist yet. Therefore, I'll post an event that says the snapshot doesn't exist yet. I'm waiting, and then the user can go look and find out why his PVC isn't bound yet. But again, if we use some other CR as the data source that the external provisioner sidecar doesn't understand, again, it doesn't know how to provide you feedback. So there's two ways to address this that I thought of. One is that if we presume that you'll always install the populator sort of controller alongside the CRD that specifies a certain type of data source, then the existence of the CRD could be a signal to end users that the populator is there and that it works. You know, if the populator hasn't been installed, the CRD wouldn't be there, and then attempts to create instances of that data source would simply fail because Kube API server would say, I don't know what that is. And that might be good enough, but I had a better idea that would be more robust, which I'll mention here. We could create a new CRD for the purpose of registering populators. So this CRD would be installed alongside the external provisioner sidecar, and would allow populators to basically create an instance of this CRD that would specify that, you know, the kind, the API group and kind for the thing that they understand, and any other metadata that you wanted to include that would be helpful to the external populator. And then when the external populator saw something it didn't understand, it could go consult these CRs and say, oh, okay, I see that there is a populator for this kind, and therefore I can expect that somebody is going to do something with it, and they're responsible for providing the user feedback. But if I don't see anything, then the external provisioner sidecar could say, you know what, this is probably a user error, and I can post feedback immediately saying there is no populator that's going to handle the data source that you asked for, so don't sit around waiting. You know, you have a problem. And I actually am starting to like this proposal for, you know, so that you could have multiple types of data populators and they could all just instantiate CRs saying the kind that they support, and that's how you would sort of
Yeah,
register them with the system.
I like this third option. I think I proposed it earlier as a data
Oh,
source CR.
okay.
The problem I think I had with it, or that I was trying to figure out, was how to make it coexist with what we already have with snapshots, since
Yeah.
snapshots doesn't use this. But I mean, we can say, yeah, that's a one-off that doesn't follow this pattern, maybe.
Or we could, at the time we install this new CRD, just create one for volume clones and create one for snapshots.
That's
just
true.
to have them there. There's no reason we can't just, I mean, even if they get ignored, they can just be there. Or maybe in the future, we would want to decompose the external provisioner sidecar even more so that those jobs would be outsourced to something else, potentially. I don't know. My last slide, real briefly, because I know we're running a little short on time, is about CSI. So this whole presentation has been about the subject of generic data populators. You know, populators where you can just write a pod that just does the work. You don't need to know anything about the guts of the storage underneath. As we all know, that there are certain types of things where the storage underneath has to be involved, like cloning of snapshots, like cloning of volumes. There are some that are in a gray area, and I'm thinking specifically about restoring backups here, where you probably want a combination of both, where in some cases, you want a CSI interface so the storage controller can do some smart version of restoring a backup, but you also want a way to just have it work generically, so that for CSI drivers that don't support that specific type of thing, you have a sort of a fallback way of handling it. And so I have another POC that I did, I don't know, 6 months ago that sort of demonstrates this, which is, you know, you could have a certain type of CR, which is a data source, and then the fields of the CR could have enough context that the external provisioner sidecar could figure out whether it should try to do the restore through CSI or whether it should just let some external data populator handle this one. And that would be, you know, on a per CR basis or per CRD basis, you know, figuring out what that protocol is for should it be done through CSI or should it be done through the generic populator. So I just wanted to throw that out there, that I believe this is still a solvable problem even with this external populator approach. We just have to do it on a CRD by CRD basis and then put the logic into the external provisioner sidecar at the same time you implement the CSI bits for that type of data source.
For the CSI approach, it's like each driver has its own way of populating, or each driver has multiple way of populating?
Like, imagine a future where we have backup APIs in CSI itself. So like when you're doing a restore of one of those, the external provisioner sidecar will be the thing where that code lives, right? Because it has to call the CSI RPCs and say, create a volume from this backup. And so when we define with those RPCs, and I have a prototype that works, you would have some other things that would give it enough information to query and say, do you support this? And if it says yes, you would do it. And if it says no, you would say, okay, I'm going to let somebody else do it. And that would just be part of the new CSI RPC for that type of thing. If that makes any sense. I'm being very hand wavy because I want these to be
backup,
generic solutions.
Right, but I'm thinking of backup, it could also have multiple different backup devices even under that, right? Even for the one single CSI driver. So I'm guessing.
Well, I mean, but you're going to have an object in Kubernetes that refers to the backup. That has whatever metadata is necessary to understand where it is, what it is, how it is. All that stuff you should be able to get from what's in Kubernetes. And then the theory is you could have some sort of a query mechanism or a test that the external provisioner calls the driver and says, can you restore this? And here's all the data you need to know. And it could say yes, in which case it would do it, or it could say no, in which case you could punt it back out and then someone else would do it. And all the specifics are very vague because I don't want to tie this to the design of backup and restore because that's a larger subject. But yeah, this is my theory for data populators, and we do need to figure out how to handle that. Wait for first consumer thing. That is an open issue at this point.
Ben, I got a question for the option 3 just mentioned. We have the
Mm-hmm.
CR. So I can imagine that the CR you include in the PVC will be just the namespace and the name of the CR, right? You will not include the type of it, right? That begs the question.
No, the CRD to register data populators would include the API group and the kind only, because that's all that the external provisioner has to go on at that point. It's looking at a data source field of a PVC, and it has an API group and a kind and a name. And so it looks at the API group and the kind and says, I don't know how to handle this because I only know snapshots and volumes. So I need to go see if someone else knows what this is.
Yeah, the other benefit of that approach is that you can point a data source to a PVC to no data source. And so now you have the ability to differentiate between, I have created a PVC and it has a data source, but I didn't really create the CRD for that data source yet. So please hold off on making this volume available to the consumer. So there's no kind of races there. It's just an added benefit. Really follows that classic Kubernetes model. If you can create objects in different orders and expect them to converge to the correct state.
Yeah, that was something that I wanted to achieve here, so that you could do things out of order and still get success.
I see. So basically, in the PVC, you only hold the CRD information, versioning information, not an actual CR.
Right. Yeah, so like for the Hello World populator, all you would do is you would have one instance of the CRD that says, API group is hello, and then a kind is hello world or whatever. I forget what I used, but and that would be all. And then the external provisioner would say, okay, if I see one of these, I'm gonna just say that's fine. And if I see something that's not registered, I will report an error and say this looks fishy. But then that punts all the feedback responsibility for hellos to the Hello World populator. It has to see them and act on them and report status on them.
When you say registered, you mean the type exists in the API server, right?
I mean, an instance of a CR exists that mentions that API group in kind.
Well, if you do it that way, then in your populator, so you've got a populator record that tells you what to populate from, right? So are you expecting that would have things like credentials, bucket ID, all that kind of stuff would be in there?
I'm envisioning this a lot like the CSI driver CRD, where you basically only have one or two of them in the whole system.
Right, but then we have things like storage classes and stuff.
Yeah, this is orthogonal storage classes. This would just be, that all of the all of the populators that the administrator had installed in the cluster would each have one CR that tells the external provisioner sidecars, that type of data source is one that it should not throw errors on.
Yeah, no, it's just we're working through some stuff right now where we've got multiple backup repositories, for example, that we would be restoring from.
Mm-hmm.
And so there's not one for the whole system of a particular type, there's multiples.
But it would still be one controller whose job it is to create PVs and bind them to PVCs for things of
Right.
that
So
type.
then it's like, I guess the question is, where would we put the info about? Maybe it's just a
Well, you're
CR
just registering
reference in there?
the existence of that controller so that the external provisioner sidecar knows it shouldn't throw errors. And then what that controller does is up to it.
So you're not really
Yeah.
giving the name, you're only giving a kind basically of that.
Yeah.
So
Yeah.
Yeah, and then you have like it's
I mean,
gonna be like a free-form list of params for the populator itself.
The only other things that I would put in that CRD would be stuff that would be relevant to the external provisioner.
Right. No, not the CRD, but the data populator source itself. So you say populate from this source.
Those can be as complicated as you want. I mean, I imagine we'll end up with lots of them over time. The point is to define a mechanism so that they can play together and so that the implementations don't touch the core very much. That's the goal.
Okay.
All right, I put a link to these slides in the agenda if you want to view them.
but the data source field, I think that one requires a name though, right? That one.
Yeah. In the PVC
Right.
instance,
Yes.
there's the name, and the populator will actually go read that and then see that it exists. But you have these situations where you create the PVC first, and then the data source second, and so the first time the populator sees it, it'll say, "There's nothing with this name," and it'll put an event out on the PVC, and then later when the user actually instantiates the source and it retries, it'll say, "Oh, now it's there. Now I know what to do, and I'll go on with my, But you can do it out of order, and that's fine."
Okay.
All right, that's all I had.
A last quick question, Ben. The last slide you mentioned the CSI case, right? Where, for example, the backup exists in the CSI. Have you thought about the other option of not having external provisioner completely in the picture, but instead of having another, whatever we call it, CSI restorer, whatever it is, to carry that job, so that not to complicate the logic in external provisioner?
Well, I mean, the external provisioner is already handling 3 different types of things. It's handling empty volumes, it's handling clones of other volumes, and it's handling clones of snapshots. And we could start to decompose those into separate controllers, but it kind of made sense because so much of the logic is shared. It kind of made sense to combine them.
If it is your approach of, it depends on how the CSI interfaces. We can discuss this a little bit later.
Okay.
But I
think we could go either way on that, but the pattern so far has been to just keep adding to the external provisioner sidecar as we add new things you can create volumes from. And the only thing that's new with the data populators is like, this doesn't require CSI at all, so it doesn't make any sense to put anything in the external provisioner
That's right. That
sidecar.
piece is, there's no ambiguity, yes.
Okay.
I think that depends
on
how we do this restore, right? So if we just say we have a very simple process, just say create a volume from a backup, just like one step thing, that maybe makes sense to add it in the existing external provisioner, but if it involves more steps, then probably need to be handled by a separate controller.
Yes, exactly that. If we could do it in one step, we would just put it in the external provisioner and be done.
Right. Okay. Any other questions, comments on data populator?
This looks like a good high-level design, I think, or direction at least. Devil is going to be in the details, of course.
But
So
if
I
you
look
look
forward to,
at my source code, you'll see a lot of devils.
yeah, that will be fun. But I'm excited about where this is going. So thank you for following up on this.
Okay.
So all you are prototyping right now is in that hello populator repo, right?
That one repo has all the code you need to actually try this out and see that it works.
Okay.
And I probably need to go back and make some updates to it, but it was working as of a couple months ago.
Okay. All right, thank you. So going to our next topic. Let me share my screen. So the next one, so we want to give an update on the container notifier proposal. We talked about it before. We had a meeting with the SIG node on this, and one alternative suggested from that meeting is to have a way to probe what happens to this container notifier. So this is the proposal. I think we went through this one last time, and then I just want to go through and share with you what comments we got, so what update we have done so far. So now in this proposal, we have a container notifier and paired with a probe, so that basically the kubelet will first run this command in the container to do something like quias, and then paired with another command, which is from this probe to check whether this container notifier call actually got what we wanted to get. So so the comments I'm getting, I think there's one comment was saying, because initially we had a container notifier probe paired with the container notifier action. So Tim was saying that, well, actually the probe will need different ways other than just this exact, we should also allow HTTP. So there was actually already a existing probe struct here. So we can just go ahead and use it. We don't have to invent our own. So this one, you see this probe, this is in the core API, it has a handler, and the handler has a and has the definition for HTTP request. And then this has a, all of this time that you can define. So initial delay, how, the time that you want delay before you start to check this. And then the timeout, how often to do the probe, successful. So you run it once, you think that means it's successful, or you need to run multiple times. So for us, I think it's once should be enough. And minimum failure. So if you run this several times, how many times you try, and then you declare that, okay, failed. Didn't get what we want. So if you see this, I just want to go here. So this is the handler, right? So this is basically, in addition to this, exactly, you can define command. You can also have this HTTP. So that's one additional thing if we use this existing probe struct. And the other comments we got, okay, and there's another comment we got is regarding the name of this container notifier. So this is a team suggestion. I think initially this one was saying it must be a DNS label. So here, this change here is that we can have some well-known names that does not have any prefix. So for example, if you want to say Quias, this is a well-known reserved names. So we can have that. But then if we want to define customized ones, then you can just have a prefix. You can have a, the prefix and example.com and then your label style name for this notifier. So that's another comment. And another one I want to mention is there's one from Seth from Signode. We initially have this notification status. So when user create this notification object to request a container notifier, it will, it can get back the notification status from kubelet. So initially we just have this defined as conditions, but actually because we can actually have multiple containers within the pod that has the same notifier name, because in that case, we just send this request once, all of them will run. But our status did not really consider those, at least in our previous proposal. This is just like one status. There's no way to differentiate whether it is successful for one container and failed on the other or not. So, so this is a new notification status. This is actually from our previous proposal for the execution hook. We have some similar type of status like this. So here, instead of just one single status, we would have a list. So we will have an array of container notification status, and each container notification status will have a pod name, container name, and then whether it is successful or not, and arrow, and then when it has started. So we have all of this, and we can know whether it is successful in a particular container or not. And then based on that, the kubelet can retry only the ones that have failed instead of retry everything. So that's the change. This actually makes this proposal a little bit more complicated. Any questions so far? Okay. And other than that, we still have not really reached the consensus yet. So here's some comment. Basically, this is from Seth, basically thinking that he basically does not agree that kubelet must be the one that is running this command, but not, he does not agree the assumptions that we make that if kubelet is the one running this, it will be safer than if we let an external controller run this, using the exact sub-resource. So I think mainly that's his, that's actually the, this is actually from the Signal side. That was what we got last time as well. They are still not quite sure about this approach. So we need to have another meeting to discuss and hopefully to make some progress.
Xin.
Yeah.
So do you know how much overhead if the kubelets want to execute the support? For example, the user says crazy number to do the retry, and there's a multiple port that's keep retrying that. I think probably that is a concern from the kubenode SIG. Yeah,
definitely. Yeah, I can definitely see that. Yeah. If it's just up to me, I would be thinking we don't really need this probe because we already have the status in, this is not even the probe part. This is we are only talking about the first container notify action part, right? So we get all of this status already tells us whether it is successful or not. Why do we need another probe to check whether whether we have reached the status or not, right? So it sounds to me it's like redundant, but I think initially their concern during the last meeting was that there's no guarantee whether it is successful or not. So they want to be able to have a reliable way to check, but it's, yeah, you see, I can see that definitely it's going to take longer, right? Because you want quotes to be really quick. You don't want to wait for that long, but then if we do this way, you first basically run the command in container notify action, and then we're checking the status, retry. So then finally that returns success. And then you still need to make another call using a probe and then wait for that to come back, right? So yeah, I mean, in my opinion, this is not really necessary, but we are trying to address their concerns. But also I think probe is optional. It's just we need to provide something like this. So if it is provided, then kubelet will run those. But yeah, but I can definitely see the overhead that we are adding to kubelet. Yeah. So, Xiangchen, you want to add anything to this?
No, you covered everything. I don't think the problem is really a problem over here for the latency concern. Because action anyway it returns, then you can update the status anyways. Probably just a more stable status to status query.
Right, then you basically make another, just saying that you have to make another call and then for that to come back, right? But hopefully it's quick. But it definitely make it more complicated if you have to add all of those. And then especially I was looking at the, actually not even the probe. I'm thinking that if we are using the probe, since it's an existing struct, we just follow whatever has been done for the probe. But for this one now, since we actually need to have different status for each container, so this part is getting a lot more complicated than, initially we'll just say, okay, we're going to call, we always just make this one call to all the containers that has this notifier, but now we're saying, okay, we are only calling the specific ones, right? So that part then basically kubelet will have to differentiate. Then that's something extra. So yeah, so that's what we have so far. Any other comments, questions about this? Okay, let's see what. Okay, so if not, then let me go to the next thing on the agenda, which is the voting group update. So I scheduled a review meeting tomorrow. I think I sent invite to data protection work group and also SIG storage, and hope everybody has received the invite. So the CAP, we reviewed it a few weeks ago here, because I thought we won't have time to review it in this meeting since we have other agenda items. So I basically set up another meeting for this. So we can go through more details tomorrow, but there's actually, I realized there's one thing I have not addressed here. Maybe let me actually ask folks here. So this is some comments. So the Sad added this one from last meeting. So I think I have added those in the spec. There are different options when you create a working group, the volume group, and then different storage vendors may support different things. So we did get some feedback. We got this from Tom, and I think mainly from Tom. And then I think there's one thing that I'm still not quite sure about. I think that's this part. I was just reading it before the meeting. For the for the restore, there'll be multiple possibilities. Group snapshot returned, only one group snapshot ID, but not individual snapshot IDs. There must be a group snapshot ID. I don't think I addressed this one in the updated cap. And then the second one is the use case. Then you have individual volume snapshot IDs. So I remember this one. Is this one brought up by Ben? I believe, right? Ben, are you still there?
Yes. Sorry, I was stuck on mute. Go ahead.
Yeah, so I was just having a question because I actually forgot this one, and when I was updating the cap, and then I just noticed this one before today's meeting. I just wanted to get more information from you. I think this one, so for some storage systems, when they create a group snapshot, after that's created, it can only return a group snapshot ID, but not individual snapshot IDs. I think this is a scenario you brought up, right? If
well, yeah, I didn't write these words, but
they summarized this one in.
Yeah.
But I thought I remember I think you mentioned something like this because I was not actually aware of this one because.
Basically, every flavor that you can imagine of this has been implemented somewhere by somebody,
and
some of them.
I guess I want to see how common this one is. The only reason I'm asking is because I didn't run into this one previously.
Okay, so the one we're talking about is group snapshot returns only a group snapshot ID, not individual snapshot IDs.
Yeah, not individual. So is there any storage system that are not able to return individual snapshot IDs? I mean, I just want to know how many storage systems are there.
Well, so the reason you would end up in this boat is if your implementation of group snapshots was to basically put all of the PVCs, the Kubernetes volumes inside one so-called volume in the storage backend. So like if we have
one volume.
Yeah, so basically what you could do is you could have one volume on the back end and call that your consistency group. And then all of the PVCs could just be things inside that volume, whether they're subdirectories for NFS or whether they're individual files for LUNs or however the storage system structures whatever it does. Like the idea is you only end up taking one snapshot because it's all in the same place anyways.
But then you do have all the PVCs, right? You have multiple, let's say you have, let's say 10 PVCs. Then for each PVC, you would have a volume handle?
You could do that. I mean, we have drivers. NetApp has drivers that do this.
But I'm just saying that you have to, right? In Kubernetes, I don't think you can have a PVC without a volume ID. I guess that's the part that I just want to understand more about this use case.
You get the volume ID, yes, but the.
But if you can have a volume handle for those 10 PVCs, why you cannot have snapshot handle for all the snapshots? I guess that's my question. The corresponding ones. Even if you maybe
so you could the point is you could make them up, but in reality there's only one thing. So the act of deleting the made up things would be nonsensical. You just wouldn't mean anything. You'd have to. But
you do have 10 volume handles. I guess that's my. I'm confused with that. Okay. So you can still so I think you can still have those. You may not use them. I think what I'm trying to understand is I think you may not need to use them during the restore. You're saying that you don't want to like create one.
What I'm saying is if the next level up in the layering requires individual ones, we will have to synthesize them and basically make fake ones that point back to the common one that actually exists. And then we'll have to manage those, and we'll have to reference count and handle the delete case properly. There'll be all that ugliness. I mean, it's not an unsolvable problem. It's just what I'm saying is we have to make them up if they're necessary.
Okay, so is this mainly for like the shared file systems? This type of case? Does this also exist for block?
Yeah, it exists for block on our systems. I mean, we can do this where you put multiple LUNs in the same NetApp volume, and they're different volumes from the Kubernetes perspective, but there's only one volume on our storage controller, and you take a snapshot, you get a snapshot of both things. And we do that because it's cheaper in the and how much memory and CPU it consumes on our storage controller. If you group multiple LUNs together in the same volume, you get economies on CPU memory. And it allows us to get larger numbers of LUNs in the end. So for people that need like tens of thousands of these things, it matters.
But then why do you need 10 PVCs? Why don't we just have one PVC?
You can just have one PVC, but if you want to establish a consistency group.
No, I'm just saying that if instead of since they are actually just is there any need to really have 10 PVCs in that case? I'm just trying to see the.
Yeah, because they're independent things with independent lifetimes and independent users. They could be owned by different users in different namespaces. They can be deleted and resized independently. All the things you can do normally exist, except for snapshots. What we can't do is take a snapshot of just one of those things.
Mm-hmm.
We can only take a snapshot of all of those things together.
But I think that's only true of the NetApp case, right? So at HPE, we have different solutions where you do need each of those snapshots, and you can snapshot them individually.
Yeah, and like I was, NetApp does both. We have cases of both, depending on which driver or flavor you use.
But basically, you say that you can actually work around this. I guess that's what, because I have not heard about this type of thing before, so I just want to understand that.
I mean, anything can be worked around. I think it's just a case of how complicated it's going to get.
No, but if we let's say if at restore time, if we also need to accommodate that and also accommodate the other case, then that means we okay. So that actually means we need to create a PV, create a volume group and have a source as a group snapshot, and then do that in just like in one shot, one step.
Oh,
I think we removed that. I think I just removed that because it's like more complicated. At least I'm thinking maybe the first step, we don't do that if it's actually workable. And that's also not like most people probably is not in that situation. Because otherwise we have to support both, right? And that's more complicated, I guess.
Yeah, I mean, what you want to avoid is anything that makes assumptions about how the storage controller does what it does. But unfortunately, like if you're too relaxed about it, then it's not useful. So you have to make some assumptions somewhere about, well, either these things are mutable or they're not mutable, or I can restore them one at a time, or I have to restore them together. You got to put a stake in the ground and say, okay, this is how we want it to work. And then for some set of backends, they're going to say, okay, I just can't do that thing.
Right. So I was, this is of course mostly based on what we already done, right, in Cinder and also in Manila, I think. So I always thought number 2 would work. So I'm thinking that I'm leaning towards we will start with this, and then if in the future there's a need to do this one, then. But I think I still need to think more about how the controller is going to handle this. We probably should just let the CSI driver to handle this.
So you're saying you wouldn't have a group snapshot ID at all. You just have
we'll have group snapshot, of course. Otherwise, then what's the point of having this cap? Right? So we need to have a group snapshot. I was talking about restore. I'm only talking about restore time. So maybe I didn't. We can talk more. I think we are almost out of time. We can talk more tomorrow. Let me think about this one a little bit more. I was just thinking about this, like when you restore.
So in the case of the driver I was talking about, you can only take a snapshot of everything or nothing, and similarly, a restore will give you everything. So if the end user workflow is I'm going to restore 10 individual things. We obviously don't want to restore everything 10 times. We would have to play some game where we remember that it's already been restored and then give you handles to the things that we already restored when you tried to restore the other ones. And that gets bros.
Yeah, or you can have to do something maybe inside the driver just to manage that until like 10 them are restored, then you're claiming that, okay, that's done. Otherwise.
But I mean, to be perfectly honest, the most likely outcome is we would just decide to not do it. We'd be like, okay, this is too hard, and we don't care enough about that specific driver supporting this specific feature, and we'll go do something else.
Right. Yeah. So yeah, I think it's also think about like if we have to support all the cases, then maybe it's at least especially in the beginning, right? When you initially trying to put together a proposal, you want to do everything, then it's getting really, really complicated. So yeah, so let's talk more about that in tomorrow's meeting.
Which meeting are you referring to tomorrow?
You didn't get I hope everyone get a invite. I sent
okay, there's a one-off meeting at 11. I see it.
Yes, that's that one. Yeah.
Okay.
Yeah, 11 Eastern time. Yes, that's the one that, because I think we need more time. We probably need an hour to go over the whole thing. But so I thought today we won't have enough time. That's why I scheduled a meeting, one-off meeting tomorrow.
Sounds good.
All right. Anything else? Okay.
Quick question, Jing. In the meeting tomorrow, are we using Zoom or Google Meet?
I'm sorry?
I think the invite has both a Zoom and Google Meet in the invite.
It should be the Zoom. Did I send something else? It should be Zoom.
There is a Zoom link, but there's also a Google Meeting link.
For the volume group one? That's weird. How do I get that?
No problem. Just wondering which one to use. So.
Must be generated automatically. I don't know. That's pretty strange because I didn't request one. I just I created the invite in the Google Calendar.
Yeah, no problem. Just curious.
Yeah, just use the Zoom meeting. I think I see this with other meetings as well. I don't know why. Yeah.
When you edit your Google Calendar invite, you can remove the video conference link.
Oh, you can? Okay. So maybe I will I will try that next time. Thanks, Sad. You got the invite, right?
I did, yes.
Oh, okay. All right. Okay.
Thank you.
Yeah, no problem. Anything else? If not, that's it for today. Thanks, everyone.
Thank you.
Thank you. Take care.
Thanks.